I'm curious, do you believe that voice is really gonna, particularly in the time now where touching has becoming such a tricky subject, have you seen an uptick on voice usage? Have you seen an uptick on that area? And do you believe we're gonna see more of that?
Massively. We've seen a massive uptake in voice. I mean, I have the same problem like you in the home. My youngest son is called Alex. So imagine when we just call Alex, and then Alexa thinks we talk to her. So I'm just...
Hello, my name is Robert Schmidt. I'm Deloitte's Chief IoT Technologist, also known as Mr. IoT. Welcome to another coffee chat today with Dirk Didascalou. He's the VP of IoT at AWS. Dirk, how did I do with your last name?
Perfect. Fantastic. Better than ever.
Das ist unsere deutsche Sprache.
Yeah, it's unsere deutsche Sprache. Yeah, it's the Greek part of my deutsche Sprache. Yeah. I'm half Greek, half German, so that's why I have this funny accent. It sounds like Arnold Schwarzenegger with a Greek name.
Ah, interesting. Nice one, nice one, nice one. So Dirk, welcome to the show. It's great to have you. I really have people with such a colorful background as you on the show, and also with such an interesting role in today's time. Tell us a little bit about you. Tell us a little bit about your background. I'd love to hear more about that, and then we'd love to dive into what is IoT to you?
Okay, thanks. Thanks, first of all, having me on your show. I think it's a coffee with Robert. So I don't have a coffee, but I still have some water. So I will drink water with you. So cheers first. Thanks for having me. Yeah, about myself. I have the fancy title of the Vice President of IoT for Amazon Web Services. What that means is that I'm responsible with my teams for all the software services and tools that Amazon Web Services is offering specifically in the area of the Internet of Things to our customers. Originally, AWS was built, of course, for IT. That's what we do, compute, storage, and networking. And then we figured out, oh, there's more than IT equipment connecting potentially to the cloud, and what intricacies and what special things do we need to build? And then we started 5 years ago, and now have most likely one of the most comprehensive IoT solutions in the world. So that's what I do professionally. Privately, as you can hear, my mother's German, so as I said, my German Schwarzenegger accent I can never get rid of, and I'm half Greek. That's my father's Greek. That's why I have this funny Greek name. But now 6 years in the United States, most of them with Amazon Web Services, having really the pleasure of working in the Internet of Things, which was a topic I wanted to work on because I came originally from Nokia. I don't know if you remember that company, which makes the things which hold you up next to your ears, phones. So I did consumer equipment, a lot of assets, billions, literally billions of phones. That was my first life. And my second life is now with Amazon Web Services, IoT, more in the enterprise space.
So tell me, so like this transition from phones to IoT, I often, when I think of IoT, I think the phones were actually the first Internet of Things, if you really think about it. But what's similar, what's different? How do you look back at your time, and what do you use, and what do you say, yeah, I'm gonna leave that behind, that doesn't fit for IoT?
Oh yeah, it's actually very closely related. I mean, I'm always joking that I'm saying the Internet of Things was born, or the child, out of the mobile revolution and the internet revolution, because you need two things for IoT. One is the big cloud. It's all this compute and networking that only the internet gives you. And the other thing is something that is a byproduct of the mobile revolution, which is called a system on chip. If you don't know if people know about SoC, if you hear this abbreviation, stands for system on chip. That was more or less a byproduct of mobile phones, that now you can build very cheap, small little chips that can do compute, but also sensing and also connectivity for a very, very affordable price. Before, I think in the 90s, you still had to pay thousands of dollars for that. Now you can buy such an SoC for $1, and you can connect literally everything. So because of mobile, which was where I come from, now you can connect everything from a coffee mug, yeah, or to, I don't know, a car, phones, but also a light bulb. And then because of the cloud, you have the power to process all of this information in one, if you like, virtual place. So that's where it comes together. And I felt I came from the mobile side. We built in Nokia billions, literally billions of devices. So really understanding what it means to build devices at scale. but then figuring out what you do with that when you have a cloud in the back end, and you can put this not only in the mobile domain, but also in the industrial domain, the automotive domain, medical domain. It's mind-blowing capabilities now, which is really what we say is difference between the IoT, the Internet of Things, or machine to machine, which I think is actually the grandfather of IoT. It's not necessary. So if mobile and the internet revolutions are the parents of IoT, then machine to machine is a grandfather or grandmother for that.
So what's different today? You know, when our grandfather and our fathers, our parents and mother and father look at IoT, what do they see that they were dreaming of? What do they see that they didn't have? What's different today from back then?
I mean, the first thing is an economic difference. Today, it's economically feasible to connect literally everything. I mean, in the past, if 20 years ago you wanted to have just what is today, or which is maybe more closer to some of the listeners, your connected home, it was just out of the whack expensive, because it was just too expensive to just connect your light bulbs or your home. It was also not secure. And sometimes it was also very big physically to just do all of this. Just the technological advances made it extremely affordable and made it ubiquitous. So you can literally connect everything on this planet now economically. The second thing was, it was very difficult to figure out, how do I process all of this information? Because if you think about it, just even a small little motor, which is rotating at a certain frequency, and if every, I don't know, second you have a few thousands of the sample points, and you have this across millions of motors, and immediately get into exponential numbers of multiplication of data. No PC can process that. You need these humongous capabilities of data processing, which is the cloud, which you didn't have before neither. And if you wanted it as a company, you had to spend tens of millions of dollars and wait 8 to 12 months or maybe 18 months before you can even build up a data center. All of this is gone. So instant access to almost infinite compute and storage at your fingertips for every single developer. It's the other part. So that's really what is so different. It was, if you like, theoretically possible. Today it's practically possible, because you have that connectivity. I can know the state of everything. I can process that information, which makes all of the difference. And that's, again, now going back from the maybe cheesy example of why mobile and internet is the brain, is the forefathers or the parents. Actually, that technology, which is so different, which allows it today. So it means now everybody can build an app. Everybody can build an IoT solutions in almost no time with very little investment.
You talked about connecting everything is possible today, and you talked about your platform connecting. I know you have a lot of interesting use cases. Give us one of the use cases that surprised you the most. Maybe a use case that surprised you the most that you didn't think before would provide value. And I'd love to sort of like separate that between the consumer side, because some of us really know that well, and then the industrial side, because this is actually where there's a lot of movement we see happening on that.
Yep. So there's not one. I had multiple of those moments. Maybe the very first moments that ever came was fish farming. So one of the first one where we're saying, what? That was when we had activist investors coming at one point in time and saying, hey, we want to do something good, from hedge funds managers. And they said, one of the biggest problems in the world is actually, how do we feed the ever-growing population? What I hadn't thought about at all at that point in time was that even today, almost a billion of the people on this planet don't have enough protein every day for their daily nutrition. And they were just making the projections saying is in 2030 and 2040, there will be up to 9 billion people. So 2 more billion people living on that planet. And that gap will just grow. And they just make the calculation saying is it's almost impossible to feed those people just with growing more cows or pigs, because that's detrimental to the environment, because of all of the methane that is produced and all of the resources usage. And what they figured out is there's, of course, a lot what you can do in algae and very specific plants, or if you have some closed system with fish farming. And so the future, or one of the potential futures of how do you have this 2030 protein challenge, which is, I believe, even in the World Health Organization, where they look at this, what are you going to do there? Because it's a really big challenge for all of us, was how do you farm millions and millions of fish? And what they figured out is if you have these really big hangars with fish, where you have think about the size of a airplane hangars, where you just have millions of fish and something goes wrong and just the fish get sick. It's catastrophic. So what they figured out, they have very elaborate IoT mechanisms and if you like applications now, where they measure everything from the intake of food and what gets into the water, the temperature and everything else, but they can literally identify every single fish. I said, what? They're saying is, look at this. They showed me a picture of a fish. And you remember when you see a fish from the side and it has this funny patterns in the water, and saying no human being can identify the fish by looking at that. But guess what? The computer did.
The computer can.
Computer vision. So what they were looking at, they have this fish and there's millions. It's not one, it's millions going across it, and they just had the computer vision, and they were figuring out, because with computer learning they could identify individual fish and see how they develop over the growth period, which was mind-blowing to me. I was saying, well, it's insane what technology can do today. And the application was, can I use this for the greater good, so they can really have potentially solutions going forward that we can actually feed everybody on the planet. So that was one of the things which was first mind-blowing me, saying, what does our technology do? And then there are many more. I mean, in the consumer space, I mean, I work for Amazon. We do lots of stuff with Alexa, as you know. Just when I see how my kids now use Alexa, and we could most likely not even live without it, because you just ask it all the stupid questions and all the important questions that you want. That is also an IoT applications, or your Roomba robot, which is cleaning your home automatically, that you don't have to do this if you have the luxury and can afford one. On the other side, then what can you do in industrial? I mean, all of the, can we really produce more sustainably going forward for much less resources, whether it's what we do with Bayer and crop science, how do you better crop processing, or we have also what we call worker safety with Module, which is building on these belts that to figure out that people don't get hit by forklifts anymore, which was another, wow, I didn't even know that there's 1,000 forklift deaths almost every year in the United States alone. So how can you prevent them? So there's almost every month or year there comes multiple of this use case where I said, oh my goodness, I had A, no idea that this is a problem, and B, that we can help solve that. So it's a surprise almost every day, if that makes sense.
Yeah, it totally makes sense. And I love this creative process when it comes together, where someone says, what can I do with this? I have this problem. And then you sit down and you sort of like brainstorming this, and then you come up with things. And sometimes you come up with, even putting it in place, you find stuff you didn't think of before. I'm sure the fish farmers, once they started instrumenting the tanks, they saw things they didn't know they could actually measure and see, and so forth.
Sure. I mean, Pentair is a company which does all the filtration systems. I mean, what they then figured out, of course, is that they can prolong all of their lifespans of their filters, because in the past, you would say, okay, change them every 6 months or 3 months or whatever the interval was. Now it's really based on the actual usage. So you can prolong the filters' lives as long as you can get, which is economically, but also sometimes you have to change them earlier so that they're actually useful. So that is all of the side effects of this, that you have a great idea, you work backwards. What do you need? Filtration systems, how do you parameterize them? How do you instrument them? And what is all of the side effects that you can get? So it's a really challenging and interesting field to be in.
So I have two areas that I'm not sure which one I want to go, and maybe we can cover both. But my first question is, have you seen, so voice commands, interacting with your surroundings by voice. I do a lot more. My whole house runs on voice, and I can control everything. And then I get in trouble when a guest stays over and says the wrong thing, and the whole house goes dark or something like this. But I'm curious, do you believe that voice is really gonna, particularly in the time now where touching has becoming such a tricky subject, have you seen an uptick on voice usage? Have you seen an uptick on that area? And do you believe we're gonna see more of that?
Oh, massively, massively. We've seen a massive uptake in voice. I mean, I have the same problem like you in the home. My youngest son is called Alex. So imagine when we just call Alex, and then Alexa thinks we're talking. So I know what that happens for. So yeah, but I think what we just see is that we human beings, we have multiple senses, and there are multiple environments where voice, listening and hearing is much more convenient. Others where touching is, and others where seeing. And in the past, we had only very little interaction modalities. Now we can use them all. Particularly voice in the consumer space is taking off like crazy. I mean, name almost every device that works with Alexa is most likely using our backend systems, whether it's your Vizio.
What about industrial? Why aren't we using Alexa more in the industrial space?
Oh, it's starting, because think about it. If you have gloves, which in your fingers and gloves, and you can't touch, or you have to have a distance because it's more, how shall I say, hazardous to be there. So there are so many situations where voice makes sense, and then there are others where it makes no sense at all. If it's super noisy, I mean, you don't want to have any voice control because there is too much noise in it. So it really depends on the modalities. If there is something where voice can be easily understood, and it's easier to do it because you don't want to take your gloves off, or you don't want to do anything which can harm you because you're too close, because you have to touch something, voice is a great, great mechanism. So we see more and more of these requests. I mean, we also see it from Alexa. Alexa is not only in the home, it's also Alexa businesses. And the technologies that we have provided for understanding voice, or making voice, so text to voice, speech services then as well, they're all available in AWS, and they typically integrate pretty well with what we do in IoT. We went so far that if somebody wanted to build an Alexa-enabled device now, that we can offload all of this voice processing, which was still done originally, some of the codecs on the device, we put this all in the cloud so that you can build darn affordable, to avoid the word cheap, devices, because you only need at least 2 microphones because of the far field and near field, but everything else, the codecs, what you need to processing is in the cloud, so you can have very cheap, again, coming back to these SoC, these microprocessors, which can now be in the penny amounts in order to make something voice enabled. But in the past, just 2 or 3 years ago, it was still $10 to $15. Now it's really down to single dollars and pennies because of this, offloading the device, putting that part, even audio codecs, in the cloud.
This is a great intro for my second part of the question, which I wasn't sure if I'm going to ask. And it's sort of this, this movement from on-prem, cloud, fog, edge. And I have this fantasy that, I mean, think about it. My switches, everything in my house, at a factory, in all these boxes, there's always a processor. There's always, I mean, we're getting to the point where all of them have processing, networking, storage, and only half of it is used. And, you know, we can do so much more on the edge. So my question for you is, how does a native cloud company like you sort of think about edge? I know you have Greengrass. I was really more interested in sort of like a bit of a strategic discussion. How does that fit for you? Do you see stuff moving to the edge? What do you even do on your own, in your own physical environments around edge versus cloud?
Okay, so in the IoT world, the edge is as important as the cloud, as I said. I mean, the T in IoT stands for things, and things are physical assets. So no things, no physical asset, no edge, no IoT, just to make that clear. So that's what I always want to say, because I come from AWS doesn't mean that we only think about the I, only about the internet, and forget about the things. Then we would not do IoT. That was one of the reasons we need to embrace saying is, if you want to do IoT, you need to embrace that a lot of what you do actually doesn't happen on the cloud. It happens where the data is generated with the sensors. It happens on intermediate gateways. It happens, I don't know, and in very many different scenarios depending on the workload. So our approach, because that was, I think, your meta question is, so how do we think about this from AWS? I'm not going into every individual service, was we ideally need to cover all of the different aspects, from the smallest microcontroller, which can be in a light bulb, to big specific edge devices, which you would call gateways, to maybe local data centers, which you still have, and then to all of the different instances in the cloud. So our approach when it comes to the edge as AWS overall is not one size fits all. It's the right mechanism, the right tool, the right service, and the right software for the right job. And that goes from owning a real-time operating system, FreeRTOS, that is now under stewardship from Amazon, which you make available for everybody for free. It's open source. And it's the world's leading real-time operating system, which can run on a small little light bulb or sensor, to everything that you can download on more standard compute like Greengrass, which is, think about it, certain capabilities do you have on the cloud bringing to the edge, to more powerful devices, which snowball edges, think about really ruggedized devices that we build, to data centers in racks that we ship to our customers, which are called Outpost, to do equivalents like this in the network edge for what we call wavelength. That is, think about it, AWS coming to the edge of the telecom network, because what if I want to have millisecond latency applications like gaming or automotive driving, or you want to be with the cloud as close as you can because of data governance. All of this different type of edge or clouds we somehow have to provide, because depending on the workload, you need a different combination. So it's not that AWS only thinks about the cloud. That's where we started, because we still believe that in the fullness of time, most of the IT workloads will end up in the cloud. Because if you don't need immediate latency, then it's just the most economic and the most secure. But whenever you have latency requirements or economic implications by, I cannot just send all of the devices that my turbine is generating because it's terabytes per hour, so I need to be pre-processing. We need to make sure that they are handled where the data is generated and also processed over there. That's why our services are spanning everything from, as I said, operating systems at the edge to all the biggest mega regions that we have and everything in between. So that's the only way to address them. So for us, the edge is not one thing. For us, the edge is everything that you need for your use case, and we try to deliver all of the different functionalities. The maybe one unifying point behind is that we try to come up with one programming model. So if you're a software developer, which is typically our main customers who want to build those applications, that you don't have to think differently if I build an application whether it runs at the edge, in the cloud, or hybrid. And that's why we put down the same primitives, whether this is messaging and PubSub, whether this is APIs and control, whether this is containers, or whether this is Lambda functions, which is now serverless compute. You can use those primitives in order to build your applications. You can deploy them in the cloud, completely in the edge, or hybrid, so that you don't have to worry about this complications, if you like, and intricacies of the different underlying infrastructure. But we try to be the plumbers who help you handle and deploy and take the best usage of this infrastructure, if this makes any sense.
That makes great sense. And I love your passion about the T and how you need to cover the T and not just the I. It's a great analogy. So thanks for that. I appreciate that. I have to say, I have this fantasy, and maybe you tell me if this is going to come true or when you think it's going to come true, that I am actually going to, like electricity, you know, you make cloud and send cloud to me. And now I have solar and I can send solar back to my electricity company. I have all these devices in my factory, anything like this, and I can sell compute back to you, or compute walks with me because it's all shared, right? My light switch only needs half of what it needs in power and what it needs in compute and so forth. You know, when am I going to be the Airbnb of compute and give it back to you? Are we going to get there? Am I going to sell my stuff back to you?
So this is now now we don't talk about technology. I mean, I'm an engineer, as you can say, so I'm really passionate about technology. Now you talk about different business models. You say, hey, wait a minute, I have a few cycles on my light bulb. I mean, they compute. Can you give me some money back? So it's an interesting idea. I mean, there's a lot about shared economics, also what you could do. I mean, one of the first steps is actually, if you like, our wavelength, where we work with telco companies now, where we're saying is, okay, if somebody wants to have what they call edge compute and the edge network of a telco company for this very fast response time, that is the first time, because it's, if you like, infrastructure that we put there, but it's then on the premises of our customers and of course our partners, and then customers can use that, and there's also some revenue sharing behind. So you're starting getting there. Of course, the moment when we manage it, then we can get it together. Whether we ever come to the Airbnb of all compute, it's an interesting idea. So I think the biggest hurdles here are not technology. The biggest hurdles here are really all of the economics ramification, who's willing to do what from a contractual basis. So I think that's more about economists than technologists, because technically that would be available and possible. So if that gives you,
I wonder if that's what we said. I wonder if that's what we said when the cloud started. It's more about economics and people than it is about technology, because we could do cloud, but it was all about who's actually buying it and how we're buying it.
Yeah.
Dirk, it was awesome to talk to you. Thank you so much. It's great to be enthusiastic with another IoT fellow who is as excited as you, as I am. So thank you for that. Any closing thoughts? Anything I didn't ask you? Anything you want to say before we close it?
Oh, there's so many things you didn't ask.
Shall we do a part two?
Exactly. I think we need a club too, because As we said, IoT is the most amazing area for me because I came from consumer. I just love the consumer space and build stuff that is in the hands of people. And I'm just started to realize how important that technology can be for every other industry and what you can do there. So, I mean, the thing is just, I mean, with Deloitte, what we do also on the side of industrials. I mean, we haven't talked at all about what we do with Volkswagen, for example. For those who don't know, VW is one of the largest, or if the largest car manufacturers in the world. We work with them on how do we optimize their entire supply chain, and not only for themselves and their 122 factories, but their entire supply base, which is another 30,000 factories and 1,500 people, 1,500 companies. So think about the economics you can get, particularly in a situation like now, where people are struggling and saying is, what can we do to make this even better? What can we do to make this more efficient so that we need less resources? So it's just something which people have dreamt about. I mean, there was this industry 4.0 already 10 years ago, and now finally maybe we can do it. So there's a lot of stuff we could talk about, which I'm mainly excited about. I came from consumer, and I now learned that the established industries, whether it's manufacturing, whether it's medical, whether it's agriculture, oil and gas, even though we believe hopefully there is a lot of things that we can do here to make it more economically and also from an environmental perspective. But there are so many things we can do with that technology, which I realized I had no idea about, and it's just exciting, and I'm hoping that we can get there with the technology that we provide. Yeah. So lots of questions we could have gone and dive deep into, but I understand so much time left. So thanks for having me.
Well, you've challenged me in a way. I had an idea, and the idea is that, you know, maybe we'll invite another German-speaking friend of ours from Volkswagen, and we'll do a three-way conversation one day and just dive way straight into deep what goes on in car manufacturers.
Exactly.
So
let's do that. I would love to.
Awesome. Dirk, thank you so much. And with this, another Coffee with Mr. IT is coming to an end. If you missed any of today's or past shows, please check out our playlist on YouTube or podcast. We're in podcast now too. And with that, I want to say thank you and have a great day. Goodbye.
Bye.